The overall goal of this work is to fabricate a photoanode for dye-sensitized solar cells with improved performance using electrospinning.
Nanomaterials are great. They show chemical and physical properties that you cannot find in the corresponding bulk materials. However, if you try to make a device using nanomaterials, this can become quite difficult. In this video, we show how to fabricate one-dimensional inorganic nanofibers and using them for a solar cell device. The directionality in the nanofibers causes the devices to have a much better performance compared with devices that just use nanocrystalline materials.
To make the precursor solution, place 10 ml of absolute ethanol, 1 ml of glacial acetic acid, 5 grams of titanium butoxide, and 1 gram of PVP, into a sample vial. Mix the solution until it has become homogeneous and no bubbles can be observed. In order to obtain a one-dimensional nanoarchitecture, we're going to use electrospinning, a simple yet rather clever technique which allows us to obtain nanofibers with several micrometers in length and only a few hundred nanometers in diameter. To prepare the needle used for the electrospinning process, cut the tip of a 21 gauge needle and sand it down using moderate grade sandpaper until the tip is completely flat. Load the precursor solution into the syringe and place it on the syringe pump. Wrap the collector plate with aluminium foil and place the protective shield around the setup.